Okay, here we go. Graphs of circles and semicircles. I don't think you've ever done this before. I think this is new. So here are the formulas. The first page is just the formulas. The equation of a circle is x minus h squared plus y minus k squared equals r squared. Circles have a center. The center is going to be at the h and the k. And circles also have a radius. So this is radius squared, so it's just the r for the radius. HK is going to be the center of your circle. R is going to be the radius of your circle. We're going to learn how to complete the square again, but not just once. We have to complete the square 2 times because we have squares, 2 squares in this problem. Before I start, when you see y equals 2x plus 3 on the ACT, you know the highest degree is 1, and you better know that you are graphing a line, right? The next one, y equals 2x squared, like minus 3, you better know that only if the x is squared that you make a quadratic equation or a parabola. So look over here, the x is to the first, the y is to the first. On this one, the x is squared, the y isn't squared. The new equation, the x is squared and the y is squared. See the difference between the formulas? So guarantee you 2 questions on the ACT about circles. The other 2 formulas on this page are equations of semicircles. So let's just go over these really quick. Y equals plus or minus the square root of r squared minus x squared. The r squared, if this is a 9, then the radius of the circle is 3. If it's 16 right there, the radius of the circle is 4. Got that? If that's 25, the radius is going to be 5. Look at these 2. Do you notice that when the y equals plus or minus the square root of r squared minus x squared makes this type of a semicircle if it's a positive? If it's a negative, it makes the bottom part of this circle. Plus or minus together makes a full circle. I try to not connect them just to show you that we're making semicircles, but 2 semicircles make a complete circle. When x is alone and the y is underneath, you also make semicircles. The positive is the right part of the semicircle, and the negative is the left side, and again it makes a full circle. So these 2 formulas are for semicircles, and the top one is for a full circle. And that's it for the first page, just explaining to you the formulas that you're going to be using. You got to know these formulas. You got to know these formulas for the test. So okay, first part of your homework, we're just starting on the parts already. We're going to graph circles and semicircles. So here we go. Notice that down here you have y minus 3 squared with an x squared. This one does not have parentheses. If it doesn't have parentheses, then it's really x minus 0 squared, right? So your center of your circle for this one is 0, 0, right? Because it doesn't have a number in the parentheses. And this is the radius squared, right? And they should have made this perfect, but this is college algebra, so this isn't going to be perfect. Isn't that very, very close to 16? Isn't the square root of 16 4? So this one's just going to be a little bit smaller than 4 out, right, for the radius. You're going to start at 0, 0 and go out almost 4 in all your directions. So just right before the 4, right before the 4, right before the 4, and right before the 4. And it's supposed to look like a circle. I don't know what it looks like on yours, but it's supposed to look like a nice circle. Okay, let's do another one. First part is just graphing. First part is just graphing. Okay, this one, x squared plus y minus 3 squared equals 4. The center of your circle is at 0, comma, positive 3. 0, comma, positive 3. So you're going to put the center of your circle at 0, comma, positive 3. And then, how far out on all the directions do you go? Do you go 4? You do the square root of 4, right? It's r squared is there. So you're going to go out 2 to the right, 2 up, 2 to the left, and 2 down. And try to make a halfway decent circle. It's not the best, but. Okay, the next one, I just want to do one more. If it said x minus 1 squared plus y plus 2 squared equals 9 or something like that. Let's just do one more before we go into the semicircles. X minus 1 squared plus y plus 2 squared equals 9. The center of your circle, x minus 1, it's kind of like when you translate your graphs. A negative 1 really means go to the which way? Go to the right. So that's a positive 1. This really means a negative 2. So the center of your circle, I'm not going to finish it. I think you get the idea. The center's at 1, negative 2, and you're going to go out in all directions 3, correct? I'm not going to finish it. I just want to explain to you, maybe you want to know whenever you shifted your graphs, a positive means goes to the left. Remember I told you that, and you guys just understand it, but I want to tell you why positive goes to the left. Because look at this. And maybe you'll go, aha, and maybe you'll go, I don't care. But there's a what sign in your formulas, even in your parabolas. There's a what sign in there, a minus sign on both of these. So look what happens. What happens when you really write it using the right form? Aha, there's the minus sign in there. Do you see why you're going to the left? Because it's really a what? A negative 2 in the problem. So maybe you're going to go, wow, that's pretty cool. Now I understand why positive, we go to the left. So, okay, last one for part 1. Last one. You have to notice that this is a semicircle, obviously, right? This is a semicircle, and the y is on the left and the x is underneath. So you know you're making either the top of it or the bottom of it. And since it's negative, you're going to make the bottom of it, right? And this is the radius squared right there. So you're going to go out 3 on all directions. Well, not really all directions, because you're only making a semicircle. You're only making this part of it, and that's it. So that is part 1, drawing circles or semicircles. I think you guys can handle that for part 1 today. Before we move on, I just want to show you something before we move on to the next part. Completing of the squares, the next part. Just to show you, circles can be like H and K can be anywhere it wants to be, the center. But for semicircles, the semicircle center always has to be at 0, 0. You're always at 0, 0 for what? For semicircles. Got that? So that's important to know that. Okay, moving on. We are going to find, we're going to find an equation. We're not going to complete the square yet. We're going to find an equation. The center's at 2, negative 3, and the radius is 5. They want you to write the equation. So this shouldn't take too long for part 2, right? So this is the x, so you're going to put x minus 2 raised to the second. Don't forget your little 2. It shows that it's a circle. What's the sign in between? What's the sign in between? Plus, minus. Let's go back to the formula. The sign is a plus in between. I've seen people take this quiz and test coming up, and they forget the little 2. That's what makes it a circle when those 2 are both squared. Okay, x minus 2 squared plus, is it y minus 3 or is it y plus 3? Y plus 3 squared equals The radius, do you just put 5 right there? Or do you have to square the radius, which makes 25? Final answer. That shouldn't take long. Okay, the next one, they gradually get a little bit harder as we go, because this one's pretty easy, right? The first one's really easy. The second one, the center's at negative 4, 6. X plus 4 or x minus 4? X plus 4. Don't forget your what on the test? Squared. Plus y minus 6 squared, correct? Okay, now it gets a little bit harder, but they told you the radius of this one was 5, so you put 25. They're not giving us the radius, so every section leads up to the next section. A negative 4, 6 is about right there, correct? I'm not going to sit there and draw out my dashes. And doesn't 1 comma 2 land right here? And the center is here, and the circle passes through this point. If it passes through this point, I know it's not perfect, but doesn't it kind of look like that? If the center's at negative 4, 6, and it passes through 1, 2, what happens when we connect those 2 points? It makes the what of the circle? Makes the radius of the circle. How do you find the distance of the radius of the circle? What do we have to do? Don't we have to do the distance formula from yesterday? Was it yesterday? Yeah, it was yesterday. So we're going to go up here and do the square root of 1 minus a negative 4, 1 minus a negative 4 squared, plus 2 minus 6 squared. This makes 5, and 5 squared is 25. 2 minus 6 is a negative 4. A negative 4 times a negative 4 is a positive 16. Anytime you square anything in math, it's positive. It's the square root of 25 plus 16, which is the square root of 41. That's the radius of your circle, is the square root of 41. That's the radius. But the formula here is r squared, right? So what happens when you take the square root of 41 and multiply it by the square root of 41? You're going to get 41. Final answer. So these just get a little bit harder. Here comes the next one. You're going to have one like this one on the test, so you have to know what you're doing. Your circle, I didn't say that though. Your circle is tangent to both axes. Tangent, what does tangent mean? Your tangent. It's not SOHCAHTOA either. It's not trigonometry. What does it mean when you're tangent to both axes? Do you go through both axes? Do you just touch the axes? What does tangent mean? Touches it, right? Touches it. Your circle is tangent to both axes. The center is in the 4th quadrant. The radius is 3. Your circle is tangent to both axes. You are definitely in the 4th quadrant, and the radius is 3. Can you make a circle in the center, or put in the 4th quadrant? The center is in the 4th quadrant. Is that in the 4th quadrant? Your circle is tangent to both axes. It touches this one, and it touches this one. So it looks something like that. I don't know why I'm not making it. There, it looks something like that. Can we set up an equation for this problem? What's the center? If the radius is 3, you have to go out 3 here, and this is the radius is 3 here, and this is, I know it doesn't look like 3, but it's 3. Well, I know that the final radius is 3 squared, which is 9. I can do the end part of this, right? And I can start setting up the x plus and the y something squared, but we have to figure out what the center of that wonderful circle is. If it touches the x-axis at 3, it touches the y-axis at also out to 3. How would you say that point right there? 3, negative 3. So your x is negative, and your y is going to be a positive 3. So you know you go to the right 3, down 3. Don't forget your what on the test? The squares. Okay, that's it for that part. Now we're going to do the next part. This is on it. All of this is on the next test. Find the center and radius by completing the square. So if you don't like completing of the square, you need to know how to complete the square on circles, hyperbolas, ellipses, and parabolas. You have to know how to complete the square. There's a whole chapter of that in this book. We just run out of time and we don't get to that section. But I'm going to rearrange this. I'm going to put the x squared and the negative 4x together. I'm going to put the y squared and the 6y together. And I'm going to get rid of the negative 36 and bring it over to the right side. I'm going to learn how to complete the square not just once, but twice in this problem. The first thing I did was I got rid of the constant. You guys know how to complete the square, I hope. Get rid of the constant. Are your square parts right here a 1 out in front of both of them? Yes. The next thing we're going to do is we need to come up with a number that we're going to add to this one and to this one. That will complete the square. So here we go. What's half of a negative 4? Negative 2. What happens when you square a negative 2? And it's always positive because whenever you square anything in math, it's positive. Half of 6 is 3. Square it is 9. Whatever you do to one side, you have to do to the other side. I added what to this side? 13. That's what I have to add to this side. What do I have on that side? A beautiful 49. Isn't that nice to end with the r squared as being 49? How do you write this as a perfect square? Isn't it x minus 2, x minus 2? Or x minus 2 what? Squared. And how do you write this one? Y plus what number? 3 squared. Is it set up exactly in the form of a circle equation? So if they ask you on the test, what's the center? You still got to answer the question. You just wrote the equation. The center of your circle is at 2, negative 3. This is the center. The radius of your circle is, isn't it nice that they came up with a nice number like that? It's 7, isn't it? And that's it for that one. I don't know if I have another one of these. Do I have another one of those?
No.
I can make up another one. Anybody want me to do one more?
No.
Everybody got it? You're going to separate these. You're going to put these together. You're going to put these together. You're going to get rid of the number. I think the ones on the test, I think the ones in the book are going to be even. So that's going to make it nice for you, right? You should be able to complete the square twice so that it looks like, whoops, I forgot I do have it, equals 49. Okay, moving along then. We're almost done. Is this the last page? 2 more pages, that's it. Find the equation of all of the semicircles. Find the equation of all of the semicircles. This is supposed to be another aha. There's supposed to be a lot of ahas in this class, the older you get. So, isn't this a circle? Isn't this circle at 0, 0, the center, and the radius at 6? Everybody believe me, right? We want all the equations for the semicircle. So let's look at what equations of the semicircles look like one more time. Go back, go back. You need to get y alone to make the top of one and the bottom of one, and then you need to get x alone, correct? So that's what we're going to do. We're going to do it. We're going to come up with 4 equations. So here we go. Right here. Y squared equals, if I want to get y squared alone, subtract x squared to both sides. 36 minus x squared. We still need to get y alone. Right now we have y squared. What do we have to do to both sides? Square root. Anytime you square root in math, what do you always have to remember? Plus or minus the square root of 36 minus x squared. This is the y, the plus and the minus. Doesn't the 36 stand for the r squared in the formula? And minus x squared. So now you understand where they came up with the semicircle formulas, right? Aha, that's pretty cool, isn't it? I don't know. Let's go the opposite way. Get x squared alone. Subtract y squared of both sides. This is the answer so far, because they want you to find all the equations of the semicircles. X squared equals 36 minus y squared. To get x alone, what do you have to do to both sides? Square root, square root. You get x equals, don't forget your plus or minus, the square root of 36 minus y squared. How many formulas do we have sitting there? Really 4, right? Y equals a positive square root of 36 minus x squared, and y equals a negative square root of 36 minus x squared. Look at this. What happens if you graph this one? The center's at 0, 0, the radius of 6. 1, 2, 3, 4, 5, 6. 1, 2, 4, you get the idea. It makes something like that, right? This one, your center's at 0, 0. You're making the top of a semicircle with the radius of 6 and the bottom of it. Wow, they look the same, don't they? And then this one, when the x is alone, you do the right side of the circle and the left side of the circle with your radius of 6. Oh my gosh, they're all the same thing. Aha! They were brilliant on how to figure out the semicircle formula. They lost hours upon hours of sleep coming up with that formula, you guys. It probably took them how long? 2 minutes to figure out those formulas, yeah. So, okay, last part. Given the graph, write the equation. Last part. Given the graph, write the equation. So you'll have to do this on the test. I'm hoping you can tell that it's a -2 and a +3, correct? You can easily tell it's a -2 and a +3. You ready to start writing the equation? Ready? It's going to go x what? X plus 2 or x minus 2? Plus 2. Don't forget the what? You know how many people forget the square on the quiz and test? I bet I corrected last year 10 people forgetting the square. That's why I keep saying it, you guys, to get this into your brain. So, and the other one is y minus 3 squared, correct? We're almost done with notes. We're almost done with this problem. We only need to know what the what is. The radius squared is. And we know it goes through 0, 0. Can we figure out what the radius is? There are 2 ways you can do this. We can do the distance formula, right? And I'll do it really quick. Well, this is easy. It's 0, 0. What happens when you subtract that and square it? Don't you get 4? And what happens when you subtract 0 from 3? Don't you get 3 and square it? It makes 9. So 4 plus 9 is the square root of 13. But you have to square that, which makes 13. Do you know another way you can do it? That's where they got this from, you guys. The distance formula, they got this by using the Pythagorean Theorem. This is the what of a triangle, hypotenuse. And I went up 3, and I went to the right 2. A squared plus b squared equals c squared. Do you see that that would be 9 and that would be 4 with a squared plus b squared equals c squared? Aha! That's where they got that from, the distance formula, by looking at triangles. So that is about it. That's all the notes.